Imagine you shine a light on a metal surface, and suddenly electrons just fly off. That's the mind-blowing phenomenon known as the photoelectric effect. But here's the twist. This discovery shattered classical physics and helped prove that light isn't just a wave, it's also a particle. Today on the Physics Lab, let's unravel the mystery behind this Nobel Prize-winning discovery. Back in the late 1800s, physicists believed light was just a wave. But in 1887, Heinrich Hertz noticed something strange. When he shined ultraviolet light on a metal, it sparked an electric current. This was weird. According to classical physics, light waves should just gradually transfer energy to electrons, like ocean waves slowly eroding a rock. But that's not what happened. Scientists thought that increasing the intensity of light, making it brighter, should eventually knock electrons loose. But no matter how bright the light was, if it didn't have a high enough frequency, nothing happened. Enter Albert Einstein. In 1905, he had a revolutionary idea. What if light wasn't just a wave, but also came in tiny packets of energy, quanta, called photons? Instead of energy spreading out like a wave, each photon carries a specific energy based on its frequency. Einstein proposed that if a photon had enough energy, it could directly transfer that energy to an electron, knocking it out of the metal. But if the photon's energy was too low, no matter how many photons you send, the electrons just wouldn't budge. This explained why only high-frequency light, like ultraviolet, could trigger the effect. This discovery was so groundbreaking that Einstein won the 1921 Nobel Prize. Not for relativity but for proving the quantum nature of light. The photoelectric effect wasn't just a cool experiment, it changed physics forever, proving that light behaves as both a wave and a particle. And that's just the beginning. In the next video, we'll dive into the math behind the photoelectric effect and how it led to quantum mechanics. Make sure to like, subscribe, and hit the bell icon so you don't miss it. Thanks for watching the Physics Lab. Last time on the Physics Lab, we uncovered how Einstein solved the mystery of the photoelectric effect by proving that light comes in energy packets called photons. But how do we calculate this effect, and why did this discovery rewrite the laws of physics? Let's dive into the math behind the photoelectric effect. This simple equation changed everything. It tells us that the energy of a photon depends only on its frequency, not its brightness. Here E is the photon's energy, H is Planck's constant, 6.626 times 10 to the power of minus 34 joule seconds, and F is the frequency of light. So when a photon hits a metal, it transfers its energy to an electron, but not every electron escapes. That's because the metal holds onto its electrons with a certain amount of energy, called the work function, or phi. Only if the photon's energy is greater than phi will the electron be ejected. This equation tells us how much kinetic energy the ejected electron will have. The higher the photon's frequency, the more energy it gives the electron. But if the photon's energy is less than the work function, nothing happens, no electrons are emitted. This shattered classical physics. Before this, scientists thought that increasing light intensity or brightness should always eject electrons. But the photoelectric experiment proved that only high-frequency light, like ultraviolet, could free electrons no matter how bright lower-frequency light was. This discovery didn't just explain a weird experiment, it launched the quantum revolution. The idea that energy comes in discrete packets laid the foundation for quantum mechanics, changing everything from semiconductors to modern electronics. And that's how a simple experiment reshaped physics. But we're not done yet. In the next video, we'll explore how the photoelectric effect is used in real life, from solar panels to night vision. Make sure to like, subscribe, and hit the bell icon so you don't miss it. Thanks for watching the Physics Lab. Last time on the Physics Lab, we broke down the math behind the photoelectric effect. But this discovery isn't just a cool theory, it powers real-world technology. From solar panels to night vision and even space telescopes, let's explore how the photoelectric effect changed our world. Ever wondered how solar panels generate electricity? It's all thanks to the photoelectric effect. Here's how it works. Inside a solar cell, light photons hit a semiconductor material, usually silicon. When a photon has enough energy, it knocks an electron free, creating an electric current. Multiply this by millions of photons per second, and you get solar power. Night vision goggles also use the photoelectric effect, but in a different way. These devices detect faint light, like infrared from warm objects, and convert it into an electrical signal. Electrons knocked loose by photons are accelerated and amplified, making the final image much brighter. That's why night vision goggles turn a dark scene into a visible green-tinted image. Need to detect even a single photon? That's where photomultiplier tubes come in. These ultra-sensitive devices are used in medical imaging, astronomy, and particle physics. A photon knocks out an electron, which then hits a series of plates, multiplying into more electrons at each stage. By the end, a single photon creates a measurable electrical signal, allowing scientists to detect even the faintest light. Ever seen those stunning deep space images from NASA? Space telescopes like Hubble and James Webb use photoelectric sensors called CCD, or charge-coupled device, detectors to capture light from galaxies billions of light-years away. When photons strike a CCD chip, they trigger tiny electric charges. These signals are then processed into the breathtaking images we see of the cosmos. So, from solar energy to deep space exploration, the photoelectric effect is everywhere. Einstein's discovery not only changed physics, it shaped the future of technology. If you enjoyed this series, hit like, subscribe, and turn on notifications for more mind-blowing science. Thanks for watching the Physics Lab.